Hello everyone, I am Zara Lassi and today we will be discussing on quantitative data management and analysis. So in this presentation, we would understand the results of descriptive statistical procedures described in a research report. We would understand the results of inferential statistical procedures that are described in the research report and identify some methods of drawing conclusion about statistical results in a research report. Now, this entire session would be divided into 3-4 different presentations so that you can easily take one at a time and understand it thoroughly. All right, so let's first understand what is data and what are variables. Now, variable is any factor, trait, or condition that can exist in differing amounts of types. Now, variable whose values are determined by chance are called random variables. Like for example, if you are doing a study, the different variable that you would be assessing and analyzing about a participant, let's say for example, would be their age, their gender, their educational status, their employment status. So all those different kind of, factors that you consider in a participant can be a variable. Any disease, any particular trait of that participant are all the variables. Now, what is data? Now, data are the values, measurements, or observation that the variable can consume. So, for example, if we are talking about an age, the data that is a variable, the data would be either the participant is 18 years old or 24 years old or 34 years old. So those data or observation or their ages are the data. And what is a data set? A collection of data values from a data set. Each value in the data set is called data value or a datum. So if you are collecting the age variable of, let's say, 100 sample size, so each person would have their own age. So that would constitute a data set. Now, variables and types of data can be of many types. You can collect a quantitative data, you can collect a qualitative data. In today's session, we will only be concentrating on quantitative data. And now in quantitative data, a data can be discrete or continuous. What do you mean by discrete? Where there are values of 1, 2, 3, 4. And the continuous can be something which is continuous and has a numeric values in between. Like for example, your exam scores. Like for example, your height. Like for example, your weight. If your weight is 32.3 kg, you will report it as 32.3 kg. So that's a continuous variable. Discrete can be like for example, if you are female, we are categorizing all female as number 1 and all male as number 2. So 1 or 2 are the discrete data. Now, qualitative variables can be placed into distinct category according to some characteristics or attribute. For example, classifying a subject according to gender. So that's a qualitative one, but that when is classified can be a discrete as well. So depending on how you treat each variable, it can take a form of qualitative nature or a quantitative nature. Now, quantitative variables are numerical and can be ordered or ranked as we have discussed. So for example, if we take an example of age, there are two types, discrete or continuous. Values that be counted as 1, 2, 3, 4 are discrete, and value which has a specific, fraction value or decimal value such as temperature are the continuous. Now there are 4 broad type of scales, measurement scale. One is nominal, one is ordinal, one is interval, and one is ratio. Now, nominal level data can be the zip codes or the postcodes of the areas where a person lives. So those can be treated as nominal value. Gender can be treated as nominal value, male or female. Eye color, political affiliation, and all those kind of values are nominal. Ordinal, where, for example, something are in order. So for example, grade A, B, C, D. We know A is better than B. We know B is better than C. So they are ranked and placed in some order. So those are ordinal data. Interval are just the interval data, like for example, temperature, set scores, the IQ level, where 0 means something, where 0 doesn't mean none. So for example, 0 temperature is a temperature because it can go in minus as well. So those are interval level data. Ratio level, where 0 means nothing. So height of 0 means there is no person, or height of it doesn't exist. 0 time doesn't exist. 0 salary means no salary. 0 age means 0 age. So those are ratio level data. Now, variables in experimental and observational studies can be treated as independent variables or dependent variables. So independent variables are something which effect on the dependent variable. So for example, if we want to understand whether a person has developed diabetes or no, so here the outcome of interest on all our research is concentrated on diabetes. So that's our dependent variable. And for that particular variable, in order to understand and in order to measure the dependent variable, we are looking at independent variables. What are the factors that are, contributing in a person to have this condition of diabetes? So independent variables impacts on the dependent variables. So you treat them accordingly, independent and dependent. And sometimes there are some control variables. You control for some variables in order to understand the impact of independent and dependent variables. So for example, age, if you want to control for age and then look for the impact of independent variable on dependent variable, those can be treated as control variables. Now there are some Hawthorne effect that impacts the confounding variable. Now, what is an Hawthorne effect? It was initially discovered in 1924 in a study of workers at Hawthorne plant of the Western Electric Company. So researchers found that subjects who knew they were participating in an experiment actually changed the behavior that affects the result of the study. So for example, if you know that someone is watching you all the time to understand how you would behave in a certain situation, then you would change your behavior in order to behave nicely for that situation. So that's the Hawthorne effect. So people usually avoid Hawthorne effect in their study so that this bias can be minimized. So for example, you must have heard in the randomized control trials that people blind the participants or blind the researcher who is assigning the exposure to the participants in a way that nobody knows if that person is receiving an intervention or someone would be observing that person. So you minimize those effect from your study, and this is called Hawthorne effect. Now, before we end this particular presentation, we would end it on this slide where we are just discussing some basic statistical analysis. So the basic statistical analysis are descriptive statistics or the inferential statistic. Descriptive is you just describe your data through frequencies and percentages or means and standard deviations. But inferential statistics is that you are deriving the evidence and you are running some tests to understand how it is impacting the dependent variable, how independent variables are impacting on dependent variables, and you do some correlation tests, t-tests, chi-square tests, logistic regression tests, depending on the nature of your data. If it is, normally distributed or not normally distributed, depending on that, you picked your test, and there are several of tens of other tests that you can apply depending on the type of data you have in hand. But these are the common ones that one should always understand and know. Thank you very much. We are ending our slide here, and you have to watch the next one. Thank you.